Right. We need to complete our RSA. I discovered that it's incomplete. By the way, after multiplying your 30, your 30, your 20, and your 15, I'm sure you're going to get 0.63 something, 0.636, like that. Then you multiply this by your 55, and you get something like 34.999 something. So in a nutshell, this is equivalent to 35. 35 is your ciphertext. This is the message which is going to this is the converted message, rather. Let me put it that way. This is the converted message from the plain text into ciphertext, and this is the message which is going to be transmitted. It can be intercepted, but someone is going to view 35. It's not the original message. But on the other side now, Bob will have to decrypt the message so that he can end up getting the 30, the original message, which was 30. Here I had put 50 instead of what? Of 35. Why? Because I customized one example, and when you are trying to elaborate certain things, sometimes you might forget to change or alter the information. But well, it has to be 35. Now we need to decrypt, and to decrypt, use this formula that is given here. We now have all the variables. To get your M, which is the original message, you need your C, which you just computed, 35 being raised to the power of D, that we computed here. So being raised to the power 23 mod N, which is 55. Now the reason why I had to prepare you to do these calculations is because I know that decryption normally is difficult to enter the figures, especially into your calculator. You cannot punch them. Imagine entering 35 to the power 23. Here I could easily say 30 to the power 7, and I could get this figure, 21,000, 21 million. I don't know the figure, I will end up, giving you the wrong figure. It's 21,870, then 21, how would you call that? I'm now becoming a mini zoomer. But that's the figure that you get if you enter 30 to the power 7. But I had to use this long method because I wanted to prepare you for this scenario. So you now need your mathematical indices, the ones that you did when you were doing your ordinary level. 35 can be expressed as a product of various indices. Or should I say, express 35 to the power 23 as a product of its indices. So you have 35 being raised to the power 1 plus, by the way, they are all factors of 2 to the power n, where n is from 0 to any number. So if it's 0, you get... if this becomes 1, if it's 1, this becomes 2. If it's 2, this becomes 4. Now 4 plus 2 plus 1, that's 7. 7 plus 7 from 22, that's 16. So we omit 8 and we go straight to 16. Okay? I hope you're all following. Then you now say 35 independently now. 35 to the power 1 mod 15. 35 squared mod 15. 35 to the power 4 mod 15. 35 to the power 16 mod 55 again, not 15 but rather 55. Right, now let's do this one by one. 35 to the power 1 mod 55. If you enter it in your calculator, I'm sure you're going to return your 35. Right, so I need a different color so that at least we can indicate that 15 here it's equal to sorry. Here it's equal to 35. It retains 35. Then 35 squared, 35, you enter it in your 35 squared, that's 1225 over 55, you get 22 point. So you're worried about the decimal part, isn't it? So 0.272 times 55, you get 14.96, which is equal to 15. Then 35 to the power 4, you can enter it, or you can easily say 35 to the power 4, you get it by saying 35 squared being raised, 35 squared being raised to the power 2. This is the same. Of which 35 squared you already computed and you got 15. Are you following? Right? You already computed it and you got 15. So it's just as good as saying 15 squared mod 55. 15 squared, that's 225 over 55, you get 0.090. 0.090. Sorry, I said 225 over 55. 0.090, yes. 0.090 times 55. You get 4.95, which is equivalent to 5. Then 35 to the power 16. You can simply say 35 to the power 4 raised to the power 4. So this being the case, you are now saying 5 to the power 4. 5 to the power 4 gives you 625 over 225. 5 to the power 4, we say 625, isn't it? 625 over 55, you get 0.363. 0.363 times 55, you get 19.9 something, which is equivalent to 20. So basically, you are now computing 35 multiplied by 15 multiplied by 5 multiplied by 20, right? So you're saying 35 times 15 times 5 times 20, you get 52,500. 52,500, right? This is not correct. The 52, this one that was already written there, like I said, isn't it? I had to change that problem. So 52,500 over 55, you get 0.545. This is the decimal part. 0.545, you multiplied by 55, you get 29.97, which is equivalent to 30. What was our original message? Is 30. So it's confirming that the plain text, the original message was was 30, right? So this is how you do your RSA in terms of encryption and decryption, right? I don't know if there is anyone with a question there. Otherwise, the next thing that we need to do is the Diffie-Hellman. Then from the Diffie-Hellman, I also need to talk about Kerberos. So I'll be continuously uploading these videos so that at least you appreciate them better. Then the discussions, definitely we're going to do them. Thank you.